So here in this question it says a geometric progression, a GP, has a common ratio of -2/3 and the sum of the first three terms is 35, and they're asking us to find the first term of the progression. Now it is a good practice to write down the data you have been given. For example, we have common ratio is -2/3, r is modulus of r is less than 1, as -2/3 is somewhat -0.67, right? Hence the modulus of r is less than 1, hence this geometric progression will have a sum to infinity. In the first part, they are asking us to find the first term of the progression, and they have also told us that the sum of the first three terms, S3, series up to third term, is 35, right? So they have given us the sum of the first three terms, so obviously we will need to use the formula for the sum of a geometric progression. Now for r less than 1, for the modulus of r less than 1, the formula for the sum was Sn equals to a into 1 minus Rn over 1 minus r. So we know that S3 is 25, so S3 is, A is, we don't know what A is, we need to find A, 1 minus R is actually -2/3 raised to the power 3 over 1 minus -2/3. S3 is 35. This will become 35 equals to 5/3. A will multiply by this one and give us A, minus or plus, because this minus will persist, this negative sign, and this negative multiplied with this negative will give us a positive sign. 1 plus 8/27A. On further simplification, we get A equals to 45. Alright, now moving on to the next part, it says find the sum to infinity. Alright, so we know that r, the modulus of r is less than 1, hence the sum to infinity of the geometric progression will exist. So the sum to infinity formula was a over 1 minus r. So by using this formula we get a is 45 over 1 minus r, which is 2/3. So sum to infinity is 27. Now in the next question it says the first term of a geometric progression is 12, a is 12, and the second term is -6. Find the 10th term of the progression. So the formula for any term of a geometric progression is an equals to ar n minus 1, right? Now here we need to find a10. We have a, which is the first term, which is 12. We have n, which is 10, but we don't have r. So r, the formula for finding r is you divide a term by its previous term. So we can do a2 divided by a. That will give us -6 over 12. R is -0.5. Now here the modulus of r is less than 1, hence the sum to infinity of this geometric progression will exist because this GP is a convergent one. So now r is -1.5, -0.5. We'll plug in the values in this formula right here. So this will give us a10. A is 12. R is -0.5 to the power 10 minus 1. This will become 9. So a10 is -3 over 128. In the second part, they're asking us to find the sum to infinity of the progression. Alright, so we already proved that the sum to infinity of this progression will exist. Sum to infinity formula is S infinity equals to A over 1 minus R. A is our first term, which is 12. R is negative 6 by 12 or negative 0.5. From this we get S infinity equals to 8. Alright.